Hello, it's Mr. Thompson again with lesson number 5 on the forces. Before we begin lesson number 5, can I just make sure that you've all had a look at the video I did with answers to vector questions? I think looking through your scores, this was the hardest thing we've done so far. And I did spend a long time, about an hour, making this video and getting it down into just less than 4 minutes. And I feel it really explains how to answer vector questions. So if you haven't already done so, you have a look at that at some point, please. Today's lesson objectives, quite straightforward. In fact, it's something you did in year 7 and you did again, I think, at the end of year 8. You describe the difference between distance and displacement, describe the difference between speed and velocity, be able to recall typical speeds and be able to recall and use the equation to calculate speed and velocity. So today's all about speed and using the speed equation with an assessment at the end, as I've done every lesson, to see if you can use that calculation and see also if you understand the differences between these terms. On the spec, I'm not going to read it through. You can come back later and have a look through. I'm going to cover distance and displacement, the spec on speed, how you calculate speed, and what is meant by velocity. Okay, best way to do this, another Fuse School video on my playlist. You'll see at the top of my playlist here called Speed Distance Time, just over 3 minutes. If you want to pause this video and go to that one and watch it, and then the rest will make very much sense. Okay, the first two we're going to tackle, describe the difference between distance and displacement, and describe the difference between speed and velocity. You'll notice the top right hand corner there, I put a little notepad and pen just to help you now, boys, that if that's in the corner, this is what you need to copy into your books. It's not too much. Today your note taking should take about 5 minutes, and then time for assessment at the end. So distance is how far an object moves. Distance does not involve direction. Distance is a scalar quantity. Could be any direction. You don't know. Distance is just how far something moves. Whereas displacement includes both distance and object moves measured in a straight line from that starting point. And it has direction. Displacement is a vector quantity. Remember, we talked about vector quantities, and it means that vector quantities can have plus and minus signs. So if you go in the opposite direction, you would have a minus displacement. Whereas distance, you just have a number. You cannot have minus distances. And for speed and velocity, the speed here is a scalar, does not involve direction, just tells you how fast you're going in any particular direction. Whereas velocity is its speed in a given direction. It's a vector quantity. Again, a velocity can have a minus number, means you're going in the opposite direction. Okay, back to the lesson objectives, 2 more. Be able to recall typical speeds and be able to recall and use the equation on speed and velocity. So in your books, you can write down, you need to know this, it's been on many exams, you need to be able to recall typical speeds of walking, running, cycling. And it can depend on factors. You can go faster or slower depending on your age, terrain, fitness and distance traveled. So typical values you need to learn in red here. Walking about 1.5 meters per second, running about 3 meters per second, that's a kind of jog, and cycling about 6 meters per second. You need to learn those and be able to quote those in the exam. As well as that, you need to know that things like speed of sound can vary with wind, but a typical value for speed of sound is 330 meters per second. So the 4 speeds in red you will need to learn, so make sure you write them all down. Okay, and onto the equation. Again, I mentioned at the start, you did this equation in year 7, probably done it in maths. You did it again year 8 and 9, and now we're in towards the end of year 10, going into year 11. You need this equation. Probably the most important equation, or the most popular anyway, in the GCSE physics. Please note, just to confuse you, that we use S for distance, not S for speed. We use V for speed. V also means velocity, and T for time. So you need to write these in your book and make sure you get the symbols right. If you prefer, you can always just use the words, but if you do use the symbols in the exam, you must get them right. So S is for distance, V is for speed or velocity, and T for time. Rearranging it, if you want to put it in a triangle, would give you speed as distance over time, and also time is distance divided by speed. You'll see in the Fuse School video how to calculate Usain Bolt's speed. So here's a screenshot of the video. It stopped at that point where it shows his speed. And what I'd like you to do is, if it was an exam, this is how it would be presented. So you can write the question down as example number 1. Calculate Usain Bolt's speed, average speed in 100 meters when he's ran it in 9.58 seconds. Of course, it's an average speed because he's accelerating all the way through. He starts off a bit slow and by the end he's getting to his maximum speed. So as always, you write out the equation, V is SOT, then you put in the right numbers, 100 divided by 9.58, and you get the units. Answer with the units, V is 10.44 meters per second is his average speed, that world record for 100 meters. Example number 2, calculate the distance traveled by a cyclist traveling at a speed of 6 meters per second for 2 minutes. I'll put this one in just so you're aware. You must convert minutes into seconds and kilometers into meters and get the base units. So firstly, we must put 2 minutes into seconds, which is 120 seconds. There's the equation. Distance is speed times time. And the numbers, distance is 6 times 120, and it comes out as 720, and that's in meters. Example 3 pulls in the fact that you need to know about speed of sound, so I thought I'd put that example in. Calculate the time taken for sound reaches from thunderstorms 2 kilometers away. Speed of sound I mentioned was about 330 meters per second, so we'll use that value. So first you must convert the kilometers into meters. 2 kilometers is 2,000 meters. Then you put it in the equation. Time is distance over speed. So it's 2,000 divided by 330, and rounded off you get an answer of 6.1 seconds. That's how long it takes the sound of the thunder to reach you. So you'd see the lightning almost straight away because that travels at 300 million meters per second, so almost instantly. And the thunder takes a little bit longer to reach us. Okay, that's the end of the lesson. If you've got all those notes down, you've practiced that. As with every lesson, you're getting used to this now. You have 10 questions on using the speed equation, so you may need a calculator, although I have made the numbers quite easy, and you should aim to get all 10 out of 10. I think if you take your time through these and you've listened to the lesson, you've made notes, you should find those that you can get 10 out of 10. It would be good to see everybody's aiming for that. Okay, thanks for listening. There will be no lesson on Friday as it's bank holiday, so enjoy your long weekend, and I'll speak to you or see you next week.